Hello there, and welcome to the Sleepy Space Channel. Tonight, we examine one of the most unsettling observations in modern astronomy, the simple, measured fact that the universe, by every reasonable accounting, should be loud and is not. There are hundreds of billions of stars in our galaxy. Most of them have planets. Many of those planets sit in the temperate regions where life could begin. The galaxy has had billions of years to produce neighbors. And yet, when we listen, we hear nothing. The chain from a habitable planet to a civilization capable of being heard contains, somewhere along its length, a barrier that almost no one crosses. This is the Great Filter. Tonight we walk through the chain link by link, the long abundance, the candidate filters behind us, the candidate filters that may still lie ahead, and what the silence itself has already told us. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is something you need to carry. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. Part 1. The silence. There is a particular kind of question that does not arrive in the form of a discovery. It arrives in the form of an absence. It is not a thing seen, but a thing not seen. It is not a sound heard, but a sound that should be there and is not. The Great Filter is a question of this kind. It begins, very simply, with a sky. The sky is enormous. It contains, in a single sweep of the eye, more stars than any person could count in a lifetime. It contains, beyond what the eye can see, more galaxies than there are stars in our own. The universe is vast, and the universe is old, and the universe seems to have arranged itself with a kind of patient generosity, scattering planets among the stars in numbers that, only a generation ago, no one was sure existed. And yet, when we listen to that sky, we hear nothing. This absence is sometimes called the Great Silence. It is the simple, observed fact that the universe, despite its scale and its age and its apparent friendliness to life, has so far given us no sign of anyone else looking back. There are no signals. There are no probes drifting past the planets. There are no quiet engineering hums on the far side of the galaxy. There are no patterns of light from other stars that demand a builder. There is only the steady, almost ceremonial quiet of a cosmos that, by every measure we have, should be louder than it is. The Great Filter is the name given to whatever is responsible for that quiet. It is a single phrase that holds a long argument inside itself. The phrase suggests that somewhere between the formation of a planet and the rise of a civilization capable of being heard across galactic distances, there is a barrier. Something stops almost everything that begins. The chain of steps from a sunlit world to a star-faring society contains, somewhere along its length, a step that almost no one completes. The galaxy is not empty because the universe has not tried. The galaxy is quiet because something, somewhere in the chain, almost always closes the door before the final step is taken. This is a sobering idea, and it is worth letting it settle. The Great Filter is not a horror story, but it is not an entirely gentle one either. It is the calm, careful observation that the universe has many beginnings and very few endings of the kind we hope to find. It is the observation that, on the long arc from dust to mind, something is almost always missing. It is the observation that the universe is full of light and short of voices. But the Great Filter is also, in its way, an honest question rather than an answer. It does not say where the barrier is. It does not say what shape it takes. It only says, on the strength of what the sky has shown us so far, that a barrier of some kind must exist. The question of the filter is the question of where along the chain that barrier lies. That question has only two broad shapes, and both of them have weight. Either the barrier is behind us, in some step we have already taken, or the barrier is ahead of us, in some step we have not yet taken. The chapters of this video will walk slowly through both possibilities. They will not declare a winner. They will only set out, with the steady patience the subject deserves, what we know, what we do not know, and what the silence has already told us. It is worth pausing for a moment on why this particular question carries the weight that it does. There are many proposed answers to the larger puzzle of the empty sky. Some of them imagine that civilizations are out there, but quiet by choice. Some of them imagine that civilizations are out there but separated by such enormous distances that their light has simply not had time to reach us. Some of them imagine that civilizations are present but indistinguishable from the natural background. These are real proposals, and they will be touched on later. But the Great Filter is heavier than the others, because the Great Filter is the only answer that says something about the path itself. It says that the road from dust to a galaxy-spanning civilization has a place where almost no one survives. It says that the universe has tried, many times, and that the silence is the record of those attempts. It is the only answer to the empty sky that points directly back at us and asks whether we have already crossed the dangerous step or whether we are still walking toward it. This is why the question feels heavier than the others. The Great Filter does not just describe a fact about other places. It describes a fact about the path that connects this place to every place. It is the only solution to the silence that has skin in the game. If the filter is behind us, we are extraordinarily lucky. If the filter is ahead of us, we are extraordinarily exposed. There is no other framing of the empty sky that points so directly at the future of our own civilization. And so the first task of this video is to set out, calmly, what the silence actually is. It is not the absence of looking. It is the result of looking. It is what the data show whenever we point an instrument outward and ask the universe a careful question. It is the result of decades of careful searches across many wavelengths and across many parts of the sky. It is the result of patient instruments operated by patient people. The silence is a measurement, not an oversight. It is what the universe says when it is honestly asked. The shape of that silence is worth describing in detail, and we will come to it. But before we do, the video has to walk slowly through the reasons the silence is strange in the first place. The strangeness is not obvious if you do not know what was expected. The strangeness comes from the contrast between what the universe seems to have prepared and what the universe seems to have produced. To feel the weight of the Great Filter, you have to feel first how much of the chain has already been completed by everything except the final step. You have to feel the abundance before you feel the absence. That is the work of the next chapter. The video will walk, slowly and unhurriedly, through the long chain of conditions the universe has arranged for life. It will name each step in plain language. It will treat each step with the calm of a documentary narrator. It will accumulate the chain link by link until the chain is long enough to feel its full weight. And then, at the end of that walk, the strangeness of the silence will arrive on its own without any need to dramatize it. The strangeness is not in the volume of the silence. The strangeness is in the size of the gap between what the universe seems to offer and what the universe seems to have produced. There is one more thing to say before we begin that walk. The great filter, taken seriously, does not require us to choose between hope and dread. The filter is a description, not a verdict. It is a statement about what the data so far have ruled out, and what the data so far have not yet ruled in. It is a question that is being answered slowly, over time, by patient observation. The video will not pretend to settle it. It will only set out, in calm and careful language, what the question is and what the universe has so far given us in response. The silence will be left where the universe has left it open, ongoing, and worth listening to. The fear in the title of this video is not the point. The point is the question itself, which is older and quieter than any fear. So we begin. We begin where every consideration of the filter must begin, with the simple observation that the universe is enormous, and that the universe has been here for a very long time, and that the universe has given every appearance of being ready for company. We begin with the chain of expectation, and we begin gently, taking each link in turn, until the full strangeness of the silence is finally in view. We will move slowly. There is no hurry. The night is long, and the question is older still. It is worth, before moving on, dwelling for another moment on what kind of question the great filter actually is. It is not the same kind of question as most questions in astronomy. Most questions in astronomy are questions of measurement. How far away is that star? How much does it weigh? How hot is its surface? How fast is it moving? These are questions to which the universe gives, eventually, a number. The great filter is not a question to which the universe gives a number. It is a question that emerges, instead, from the difference between two numbers, between the number of places where life-friendly conditions exist, which is now known to be large, and the number of civilizations actually heard, which remains, so far, exactly 0. The gap between those two numbers is the question. The question has a shape, but it does not yet have a value. We will not finish this video, or any video, by writing the value down. The value is being worked out slowly, over decades, by careful observation. The question itself, however, is already in plain view. There is also a quieter observation worth offering before the chapter closes. Some questions in science feel cold. They have the texture of something measured from a distance, with no stake in the answer. The great filter does not feel cold. It feels personal, even when it is being held carefully. Part of the reason is that the question is, in the end, about a chain that we ourselves have walked. The chain begins with a star and a cooling planet, both of which were here long before us, and ends with the kind of mind that can ask the question, which is the kind of mind that is, in the moment of asking, doing the asking. The question and the asker are the same chain. The filter, wherever it lies, is something we have either already passed through or are still walking toward. It is hard to hold that observation at arm's length. The video should not try to. It should hold it close, gently, the way one holds a piece of news that is large but not yet urgent. There is a final framing the video can offer in this opening chapter before the slow chain begins. The great filter is, in some real sense, a question about expectations. The universe seems to have prepared the conditions for life with a generosity that, only a generation ago, no one was sure of. The discovery that planets are common, that habitable worlds are common, that the chemistry of life is the chemistry of the universe. These are discoveries that have arrived steadily over the last few decades, and they have rearranged what is reasonable to expect. The silence has not changed in that time. The silence has been the silence the whole time. What has changed is the expectation. The chain leading up to the silence has gotten longer and more abundant, while the silence has remained the silence. The great filter is what emerges when an unchanged silence is set against an expanding expectation. The strangeness is not in either piece alone. The strangeness is in the gap between them, and the gap is wider now than it has ever been before. The night will be patient. The question is patient. The chain is long, and we will walk it slowly. There is no need to hurry. The point of this video is not to settle anything tonight. The point is to set the question out in calm and ordered language, in a way that lets the listener feel the shape of it without being asked to carry more than the shape itself. We will begin, in the next chapter, with the chain of expectation. We will walk it link by link. We will let the chain accumulate until the strangeness of the silence is in full view. And then we will sit with the silence, the way one sits with anything that is old and quiet and worth listening to. Part 2. The long chain of expectation. The strangeness of the silence does not arrive on its own. It has to be earned. To feel why the empty sky feels strange, the video has to walk first through the chain of conditions that, taken together, ought to have filled the sky with neighbors. Each link in that chain is a real piece of science. Each link, on its own, is unremarkable. It is only at the end of the chain that the strangeness becomes visible, in the form of a quiet, much louder than the link before it suggested it would be. So, we move slowly through the chain, link by link, the way a documentary narrator moves slowly through a long survey. There is no need to hurry. The point is to let the chain accumulate. The first link is the stars. The galaxy contains somewhere between 100 and 400 billion stars. The exact number depends on how the count is made and which kinds of stars are included, but the order of magnitude is settled. There are hundreds of billions of stars in our galaxy alone, and there are hundreds of billions of galaxies in the observable universe. The stars are not rare, and they are not in short supply. Most of them are small, dim, long-lived red dwarfs, stars that will continue to burn for trillions of years, far longer than the present age of the universe. A smaller fraction are warmer, brighter, yellow stars like the Sun, which live for roughly 10 billion years before they swell into red giants and lose their outer layers to the galaxy. An even smaller fraction are larger, brighter, hotter stars that live only a few tens of millions of years before they end in supernovae. But across all of these types, the picture is the same. The galaxy is full of stars. The universe is full of galaxies. Stars are the easy step. They are everywhere. The second link is the planets. Until the last few decades, it was possible to ask, honestly, whether the Sun's family of planets was a common arrangement or a rare accident. That question has now been answered. Planets are common. The data from many years of careful survey work has shown that most stars host at least one planet, and many stars host several. Rocky planets, worlds the size of Earth, or modestly larger or smaller, with solid surfaces and the possibility of holding an atmosphere, are not rare either. The galaxy is full of planets. Where there is a star, there is, more often than not, a small family of worlds around it. The bare scarcity of real estate argument for the silence cannot stand. There is no shortage of places. The third link is something the video should pause on for longer than its size would suggest, because it is the link that gives the chain its first real weight. The third link is chemistry. Life on Earth is built from the most common elements in the universe. The chemistry of every living cell on this planet, every microbe, every plant, every animal, every fungus, is built almost entirely from a short list of atoms: hydrogen, carbon, oxygen, nitrogen, with smaller amounts of phosphorus and sulfur. These are not exotic elements. They are not the products of a single rare event. They are the most abundant elements in the universe. They are produced steadily by stars over the course of their lives, and they are scattered through the galaxy by the slow weathering of stellar winds and by the violent generosity of supernovae. The universe is, in a real sense, made of the same things that life is made of. And it is not only the elements. The molecules that life needs, the amino acids that build proteins, the simpler precursors of the nucleic acids that carry genetic information, have been found in many places beyond Earth. They have been found in the dust grains of dense interstellar clouds. They have been found in the comae of comets. They have been found in the ice that clings to the surfaces of objects in the outer solar system. They have been found in meteorites that have fallen to the Earth in modern times, preserved inside fragments of rock that have not been touched by any biology. The chemistry of life is the chemistry of the universe. Wherever life might choose to begin, the building blocks are already there. The fourth link is the simplest of the chain, and one of the most important. The fourth link is liquid water. For a long time, it was assumed that liquid water on a planetary surface was an unusual thing, a delicate condition that required a planet to be at just the right distance from just the right kind of star, and to have just the right kind of atmosphere and just the right amount of internal heat. All of those things matter, of course. But the universe has turned out to be more generous with liquid water than the older intuition predicted. There is liquid water today, beneath the ice shells of several moons in our own outer solar system, sustained by the slow squeeze of tidal forces and by the internal heat of the moons themselves. There was liquid water on the surface of Mars in the deep past, and there may be transient liquid water there even now. There is the expectation, from the chemistry of stellar accretion disks, that a substantial fraction of rocky planets in the temperate zones of their stars will host liquid water at some point during their histories. Water is not rare. The universe prepares the places. Energy is even less of a problem. Sunlight is everywhere. The geothermal heat of a planet's interior, leaking outward over billions of years, provides a steady source of energy that does not depend on the star at all. Chemical gradients in the deep oceans, where mineral-laden water meets ordinary seawater near volcanic vents, provide a third kind of energy source that depends neither on the planet's interior nor on its star. There are many ways to power a biosphere, and the universe seems to have made sure that, on a given habitable world, at least one of them will be available. The fifth link is the link of time. The galaxy is old. The first generation of stars formed within the first few 100 million years after the universe itself began. The galaxy has been hospitable to planet-bearing stars, stars with the heavier elements that planets require, scattered through the gas by previous generations of stellar deaths for many billions of years. By the time our own sun condensed out of a cold molecular cloud, the galaxy had already had about 9 billion years of practice making stars and the planets that go with them. There has been more than enough time, by every reasonable measure, for life to begin somewhere else, or commuse, for it to evolve, for it to develop technology, and for it to spread outward across the galactic disk. That last point deserves to be sat with for a moment, because it is the link in the chain that turns the chain from a statement about life into a statement about civilization. Even at speeds that are small fractions of the speed of light, speeds that are difficult, but not forbidden by physics, a patient civilization could spread outward through the disk of the galaxy in a few million years. The galaxy is large, but it is not infinite. The disk is 100,000 light-years across. A civilization that sent out probes at a small fraction of light speed and waited for them to arrive, and let those probes build new probes from the materials of the worlds they reached, could in principle have crossed the disk many times over in the time the galaxy has been hospitable. A galaxy that had been ready for company for 10 billion years should, by every reasonable accounting, have had company for a very long time already. And so we reach the end of the chain. The stars are common. The planets are common. The chemistry is common. The water is common. The energy is common. The time is more than long enough. The conditions appear to have been arranged with a kind of patient hospitality. Every link in the chain, on its own, is unremarkable. Every link, on its own, suggests that the universe is friendly to the slow work of building life. And then, at the end of the chain, the universe does something that the chain did not predict. The sky goes quiet. This is the contrast that gives the great filter its weight. It is not the quiet itself that is strange. It is the quiet at the end of so much abundance. The chain leads, link by patient link, toward the expectation of company. The sky delivers, instead, silence. Something has happened somewhere along the chain that the chain itself does not yet explain. That is where the next chapter begins. The video will take the strangeness, now in full view, and ask whether the chain we have just walked through can be sharpened into something that gives us a way to count. It can. There is a small piece of scaffolding developed many decades ago by a careful astronomer that allows the chain to be turned into a kind of multiplication. The multiplication does not give us an answer. It only gives us a way to see, in plain language, where the silencing must be happening. To that scaffolding we now turn. It is worth saying a little more about the time link, because it is the link that does the heaviest work in the chain. The age of the galaxy is something on the order of 13 billion years. The age of the universe is only modestly larger. The Sun and its family of planets are about 4.5 billion years old. The Earth's surface cooled enough to host liquid water within the first few 100 million years of its existence, and life appears in the geological record very shortly after that. From the perspective of a single planet, 4.5 billion years feels like a long time. It is a long time. But from the perspective of the galaxy, 4.5 billion years is only the most recent stretch of a much longer history. There were stars in this galaxy 9 billion years before the Sun was born. There were planets around many of those stars. There were oceans. There were continents. There were chemistries that no longer exist, in places that have long since been swept away by the slow turning of the galaxy. The galaxy was alive with the possibility of life long before the Sun arrived on the scene. What this means is that if life is at all common, there have been opportunities for it to begin many billions of years earlier than it began on Earth. There have been opportunities for it to evolve, to develop technology, and to spread outward across the disk of the galaxy long before our own planet had cooled. A civilization that arose 9 billion years ago on a planet around an older star would have had 9 billion years to do whatever it was going to do. Even at speeds far slower than the speed of light, speeds that are difficult but not forbidden by physics, a patient civilization could cross the disk of the galaxy several times over in that span of time. The galaxy is not infinite. The disk is 100,000 light-years across. Even at 1% of the speed of light, a speed we ourselves can imagine, in the long view, a civilization could traverse the disk in 10 million years, which is a small fraction of 9 billion. The implication is that the galaxy ought, by every reasonable calculation, to have had visitors a long time ago. The fact that it has not is the size of the gap we are trying to understand. There is a related observation worth holding gently. The chain of expectation is not a chain in which each link is uncertain. The chain is one in which the early links have grown more certain over time, while the later links remain unmeasured. This asymmetry matters. The silencing cannot be at the early links. The silencing must be at the late links. Whatever combination of factors produces the silence we observe, the factors that produce it must come from the part of the chain we cannot yet measure directly. The chain has been clarified at one end and remains opaque at the other. The filter, wherever it is, lives in the opaque end. The chain also has a structural property worth describing. Each link in the chain is, in some sense, conditional on the link before it. A planet that lacks the chemistry of life cannot develop life. A planet that lacks liquid water cannot develop life. A planet that lacks a stable energy source cannot maintain life. A biosphere that does not develop complex cells cannot develop multicellular life. A multicellular biosphere that does not develop minds cannot develop technology. The chain is not a sum, but a product. Each link must hold for the chain to continue. The chain breaks the moment any one of its later links breaks, and once broken, it cannot easily be repaired. This is part of why the filter is so difficult to locate from the outside. A chain that breaks at any of several places will produce the same observable outcome, a planet that did not produce a detectable civilization, and the silence does not, on its own, tell us which place the chain broke at. It is worth pausing on one more piece of the chain, the dark matter halo of the galaxy, the gas of the interstellar medium, the slow rotation of the disk, because the chain of expectation depends on the galaxy itself being a stable place over long stretches of time. It has been. The galaxy has not, in its history, undergone the kinds of catastrophic events that would have sterilized all of its planets at once. The galaxy has been a hospitable place for biology for billions of years. That stability is part of why the silence is strange. It is not the silence of a place where life had no time. It is the silence of a place that gave life every reasonable advantage and still produced quiet at the end. Part 3. The scaffolding that lets us count. There is a piece of intellectual scaffolding that quietly anchors most modern thinking about the silence of the galaxy. It does not have to be named for the body of this video to use it. What matters is the shape it gives the question. The shape is a chain of multiplications. The chain takes the abundance of stars at the beginning and the expected number of detectable civilizations at the end, and lays out the steps in between as a sequence of factors. Each factor is a probability, or a fraction, or a number, and the product of the chain is the answer. The video does not need to multiply the numbers. The video only needs to walk through the links, one by one, in plain language. Doing so lets the silence be located. The chain has roughly 7 links, though different versions count them differently. The first link is the rate at which suitable stars form in the galaxy, how often a new star, capable in principle of hosting habitable worlds, comes into being. The second is the fraction of those stars that have planets. The third is the average number of planets per planetary system that are in a region where life could exist. The fourth is the fraction of those potentially habitable planets where life actually begins. The fifth is the fraction of biospheres that produce intelligent observers. The sixth is the fraction of those observers that develop a technology capable of being detected across interstellar distances. The seventh and final factor is the typical length of time such a technology is detectable. The product of these 7 numbers gives the expected number of civilizations currently observable from any given vantage point in the galaxy. The thing the video wants to sit with calmly and with the patience the subject deserves is what has happened to those 7 factors over the last few decades. The early factors, the ones at the beginning of the chain, were once the most uncertain. They are now the best understood. The rate of star formation is known, within reasonable bounds. The fraction of stars with planets is known, and the answer is close to all of them. The average number of habitable zone planets per planetary system is known, at least in the temperate zones of Sun-like and red dwarf stars, and the answer is not small. The galaxy contains, by current estimates, somewhere in the range of billions of rocky planets in temperate zones around Sun-like and red dwarf stars combined. The early links in the chain are not the bottleneck. The early links say there ought to be very many places. It is the later links where the chain becomes uncertain and where the silencing, whatever its nature, must be doing its work. There is no measurement, yet, of the fraction of habitable planets on which life actually begins. We have one example, our own, and a single example tells us almost nothing about the underlying probability. There is no measurement of the fraction of biospheres that go on to produce minds capable of asking questions. We have, again, a single example. There is no measurement of the fraction of minds that develop detectable technology, and there is no measurement of the typical lifetime of such a technology. We have one example of the early years of the curve, and that example is too young to tell us anything about the long tail. This is the unresolved part of the chain. It is also the part that holds the entire weight of the silence. If even one of these later factors is small enough that, when multiplied with the others, the expected number of currently observable civilizations comes out close to 1, then the silence is explained. The silence is not a mystery that demands an exotic answer. The silence is the natural product of a chain in which a small number near the end of the multiplication overwhelms the large numbers at the beginning. There are several ways the multiplication can break. The video should walk through them slowly. It does not need to choose among them. It only needs to set them out, in calm language, as the live possibilities they are. One way the multiplication can break is at the step from non-living chemistry to a living cell, the step we call the origin of life. We do not know how often this step is taken. It happened on Earth within a few 100 million years of the planet's surface cooling enough to host liquid water. That is suggestive, but it is not definitive. It is possible that the step is easy and happens almost anywhere the conditions allow. It is also possible that the step is so improbable that, even given billions of habitable planets, it occurs only once in a region the size of a galaxy, or once in a region the size of the observable universe. With a single example to work from, we cannot yet tell the difference. Another way the multiplication can break is at the step from simple cells to complex cells. Earth, after life began, spent roughly 2 billion years hosting only single-celled organisms of the simplest kind. Then, in what may have been a single rare event, one cell apparently absorbed another and kept it alive inside. The absorbed cell became what we now call an organelle, a small worker dedicated to producing energy for its host. That fusion produced the eukaryotic cell, which is the foundation of every plant, every animal, every fungus, and many of the more complex single-celled organisms. Some biologists argue that this step is the single hardest one in the whole chain. It happened, as far as we can tell, only once in the history of life on Earth. If it is similarly rare on other worlds, then the galaxy may be full of simple life and almost entirely without anything more complex. A third way the multiplication can break is at the step from complex cells to complex multicellular life. Even after eukaryotic cells appeared, the further work of building tissues, organs, body plans, and nervous systems took many hundreds of millions of years and many separate inventions. Each of those inventions is a small step that, on a different world, might have failed to happen. The cumulative product of several mildly difficult steps can, on its own, be enough to silence a galaxy. A fourth way the multiplication can break is at the step from complex life to the particular kind of mind that can build instruments and ask questions. Earth has produced many kinds of intelligence in cephalopods, in mammals, in birds. But only one lineage has produced the kind of mind that builds telescopes, that writes its questions down in symbols, and that aims its instruments at other stars. The contingencies that led to that lineage are many. Fire, hands, language, the slow patience of a species willing to accumulate knowledge across generations. Each of those contingencies could have failed to occur, or could have occurred too late, or could have produced a different and quieter outcome. The kind of mind that asks the Fermi question is not the only kind of intelligence the universe might produce. It may not even be the most common kind. It is, however, the only kind from which the question itself can be asked. And a fifth way the multiplication can break is at the final factor, the typical lifetime of a detectable technology. This is the most uncomfortable of the candidates, because it asks how long a civilization, once detectable, stays detectable. Earth has been technologically loud for less than a century. The galaxy is many billions of years old. If the typical detectable lifetime is short, a few centuries, or a few thousand years, then the galaxy could have hosted thousands of civilizations and still appear empty at any given moment, simply because none of them overlapped with the rest. The silence in this case would not be the absence of beginners. It would be the absence of contemporaries. The honest expression of the great filter, in its simplest form, is that one or more of these later factors must be doing the work of the silencing. The chain begins with abundance. The chain ends with quiet. The factors that turn one into the other are not yet measured. The filter is the name we give to whichever of those factors, or whichever combination of them, is responsible for the gap. The next chapter will take the abstract idea of the filter and ask a more pointed question. The question is not what the filter is, but where it is. There are only two possible places. The filter is either behind us somewhere in the steps we have already taken, or the filter is ahead of us, in steps we have not yet taken. The video will walk through both possibilities with equal care. Neither is reassuring. Each carries a different kind of weight. And to each, in turn, we now slowly turn. The scaffolding the video has just walked through deserves one more pass, because it is the framework against which every later chapter is implicitly measured. The chain of multiplications does not have a fixed answer, but it has a fixed structure. The structure is, in plain language, that abundance at the beginning has to be reconciled with quiet at the end through factors in the middle. The factors at the beginning are large. The factor at the end, the number of currently audible civilizations, is small. Something in the middle must be small enough to bridge the difference. The filter is the name we give to that smallness. There is a useful exercise in plain reasoning that the video can offer to make the scaffolding more tangible. Suppose, for the sake of imagination, that 10% of stars in the galaxy host a planet in a temperate zone where life could in principle begin. With a galaxy of 200 billion stars, that gives 20 billion candidate planets. Suppose further that 1 in 1,000 of those planets actually develops simple life. That leaves 20 million planets with simple life. Suppose, further, that 1 in 1,000 of those planets develops complex life. That leaves 20,000 planets with complex life. Suppose, further, that 1 in 100 of those develops intelligence. That leaves 200 planets with intelligent observers. Suppose, further, that 1 in 10 of those develops detectable technology, and that the typical detectable lifetime is 10,000 years. With a galaxy 10 billion years old, we would expect 20 civilizations to have appeared at some point in that history, and at any given moment, we might expect to see, given the short detectable lifetime, only a very small number of them, or perhaps none at all. The numbers in this exercise are entirely invented. They are not measurements. They are illustrations. But they show that the scaffolding allows the silence to be reconciled with abundance through small numbers at the right places. The filter does not need to be a single overwhelming barrier. It needs only to be a few modest barriers, applied to the right factors, to produce the quiet we observe. There is a related observation about the time term that deserves separate attention. The final factor in the multiplication, the typical lifetime of a detectable civilization, is the only factor that depends directly on the civilization's own choices. The early factors are properties of the universe. The fraction of stars with planets, the fraction of planets in temperate zones, the fraction of habitable worlds where life begins, the fraction of biospheres that produce intelligence. These are facts about the galaxy, and about chemistry, and about evolution. They are not, in any meaningful sense, things a civilization decides. But the typical lifetime of a detectable civilization is, at least in part, something a civilization decides. It depends on whether the civilization keeps itself audible. It depends on whether the civilization keeps itself alive. It depends on whether the civilization keeps itself capable and curious and willing to listen. This is the only factor in the chain that points back at the civilization itself. It is also, perhaps, the factor we have the most ability to affect from the inside. The silence we observe is, in part, a statement about what other civilizations have done with that factor. Our own contribution to the long average is being made right now, in our own century, by our own choices. The video should not dramatize this. The voice should remain calm. But the observation is worth making once, in plain language, and then setting down. The filter, if it is ahead of us, is partly something the universe will do to us, and partly something we will do to ourselves, and the proportions between those two are not yet known. The chain we are walking is not a chain entirely set by the cosmos. Part of it, near the end, depends on what we choose. The honest expression of the question is that we are walking a chain whose later links are partly being written by us, in real time, with every century that passes. There is one final observation about the scaffolding that the chapter should leave the listener with. The chain is, in its full form, a chain that connects the universe to itself. It connects the abundance of stars to the audibility of civilizations. It connects the chemistry of dust to the question of company. It connects the slow turning of the galaxy to the slow patience of any observer trying to listen. The chain is not, in the end, a piece of arithmetic. It is a piece of cosmology that has been folded into the language of arithmetic for the sake of being able to think about it. The numbers are useful. The shape is more useful still. The shape says that whatever the galaxy is doing, it is doing it through a long sequence of conditional steps, each of which is at least partly knowable, and each of which has at least partly been studied. The filter, wherever it is in that sequence. We are walking the sequence ourselves. We will keep walking it, link by patient link, for as long as we are here. Part 4. The two locations of the filter. The Great Filter, taken as a hypothesis about the world, allows only two broad answers about where the bottleneck sits. The video should treat both with equal weight, and the voice should treat both with the same calm. Neither is comfortable. Each carries a different kind of weight, and a careful listener should be allowed to feel both before drawing any conclusion. The narration here will move slowly. The reason is not difficulty. The reason is that this is the chapter in which the question turns from an abstract one about the galaxy into a concrete one about us. The first possibility is that the filter is already behind us. Somewhere along the chain from the formation of the Earth to the present moment, the universe has crossed a barrier so improbable that almost no one else has crossed it. The chain looks reasonable from the inside, the way any path looks reasonable in retrospect, but on a galactic scale that path almost never completes. Most worlds, in this framing, never even take the first step. Among those that do, most never take the second. Among those, fewer still take the third, and the chain narrows further and further at each link, until at the end of it, there is, by accident or by extraordinary luck, only one or only a few that have walked the path all the way to a civilization capable of asking the question. This is the framing that feels lucky. It says, very simply, that we have already done the hardest thing. The barrier is behind us. Whatever step it was, the origin of life itself, the long jump from simple cells to complex ones, the assembly of nervous systems, the emergence of mind, or some combination of these, we have already taken it. We do not yet know which step it was. But, in this framing, we have crossed it without realizing we were crossing it. The universe is full of planets that have begun the path and have stopped somewhere along it. The galaxy is quiet because almost everyone who started has not finished. We have finished, or we are close enough to finished, that the rest is downhill. There is a calm, sobering corollary to this framing that the video should sit with. If the filter is behind us, then finding any kind of life elsewhere, even the simplest, even a single microbe on a single moon, would not be the unambiguously good news it first appears to be. Every new discovery of life on another world is, in this framing, a small reduction in our lucky margin. If life is easy, and the galaxy is still quiet, then the filter cannot have been at the step where life begins. The filter must lie further along. The more we learn about how common, simple life is, the more the silence presses against the later steps. Every biosignature on a distant world is a quiet message about the location of the filter. And the message is that, if simple life is common, the filter is not as far behind us as we hoped. The second possibility is that the filter is still ahead of us. Somewhere between our present moment and the kind of stable, long-lived, galaxy-spanning civilization the chain ought to produce, there is a step that almost no one survives. The galaxy is full of civilizations that began roughly the way we did, and ended roughly the way most of them must end, before any of them grew large enough or quiet enough to be heard from across the galactic distances. The silence is not the absence of beginners. It is the absence of survivors. This is the framing that feels exposed. It does not say what the filter is, or what shape it takes, or how close to us it might be. It only says that there is a barrier somewhere along the road, from where we are now to the long, deep future, and that very few have crossed it. We cannot see the barrier from where we stand. We do not know whether it is one step in front of us, or 100. We only know, from the silence of the galaxy, that something happens to almost everyone who reaches our position, and that the something is enough to remove them from the sky. The video should let this sit calmly. It should not amplify it. The voice should treat the framing the way a documentary narrator treats a difficult finding, naming it, allowing its weight, and then moving on to the next observation. The filter ahead is not a prediction of what will happen. It is a description of what the data so far would be consistent with. There is, as yet, no measurement that lets us tell the two framings apart. The galaxy is quiet. The chain ends in silence. The location of the barrier responsible for that silence is undetermined. There is also a softer version of the second framing that the video should name with care. The filter ahead does not have to be a death. It can be a turn inward. A civilization that develops the capacity to leave its planet may also, with time, develop the capacity to be perfectly content where it is. It may have less use for radio, for waste heat, for vast engineering projects on stellar scales, the longer it lives. A galaxy full of such civilizations would be quiet for reasons that have nothing to do with extinction. The silence would simply be the sound of maturity. Quiet civilizations are not common in the popular framing of the filter, but they are a real possibility, and the video should allow them their place. The filter that lies ahead may not be a wall. It may be a slow choice that is rarely chosen otherwise. There is also, the video should say plainly, the possibility that the filter is not a single barrier at all. It can be many quiet drains, each removing a small fraction of the population of civilizations until almost nothing remains. The chain of multiplications laid out in the previous chapter does not require one large term to be small. It requires only that the product be small. A galaxy with many medium-sized barriers, each removing 9 in 10 of the survivors of the previous one, will produce a silence as deep as a galaxy, with one extraordinary barrier, removing all but 1 in a billion. The filter need not be a single event. It can be the cumulative weight of many gentle attritions. Each of these framings, filter behind, filter ahead, filter distributed across many small steps, filter as turn inward rather than as ending, is consistent with the silence we currently see. None of them can be ruled in or out by present observation. The honest position is that we do not yet know which one is the case. The honest expression of the question is that the filter, whatever it is somewhere in the chain. We are walking the chain. We do not know what part of it we are on. This is the point at which the calm of the documentary register matters most. The temptation, when faced with a question of this size, is to lean one way or the other for the sake of resolution. The video should not lean. It should hold the two possibilities open. It should let the listener feel both and trust that the listener can carry both at once without needing one of them to be true. There is also the philosophical observation, which the video can offer briefly without dwelling on, that the filter behind us and the filter ahead of us are not perfectly symmetric. The filter behind, if it is real, would be a statement about luck. We would have been lucky. The filter ahead, if it is real, would be a statement about exposure. We would still be vulnerable. The framings carry different emotional textures, but they carry the same kind of intellectual weight. They are equally consistent with the data. They are equally serious as possibilities. And so the chapter closes. The filter is somewhere in the chain. We do not yet know where. The chain of expectation is long, and the silence at the end of it is real. The next 2 chapters will walk, in turn, through the candidate filters that could lie behind us, and then through the candidate filters that could lie ahead. We will move slowly. There is no need to rush. Each candidate deserves its own quiet consideration, and the night is patient with the question. There is one more piece of the two locations framing that deserves attention, and it is the piece that is easiest to misread. The filter behind and the filter ahead are not mutually exclusive. They can both be true, in some sense, at the same time. The chain has many narrow places, and there is no requirement that all of the narrow places be in one half of the chain. It is entirely possible that the chain has narrow places we have already crossed, and that it has further narrow places we have not yet reached. The galaxy may be quiet because of a combination of past and future filters, each removing some fraction of the population of attempted civilizations, with the cumulative product matching what we observe. The video should hold this possibility open. It is consistent with everything we know. It is also, in some ways, the most honest framing because it does not require any single step to be doing all of the work. It requires only that the chain, taken as a whole, end in quiet. There is also a calmer reading of the same framing that the video can offer gently. The chain is long. The chain has many links. Each link has its own probability of being completed. Most of those probabilities are between 0 and 1. None of them are exactly 1 in any rigorous treatment. Even on Earth, the chain of links we have walked was not inevitable. There were many places where it could have failed, on a planet that ultimately succeeded. The fact that we are here is, in some sense, a small chain of fortunate outcomes, none of which were guaranteed. The chain of expectation that the video has walked through is a chain in which each link is plausible, but not certain. The fact that we have walked it does not mean the walking was easy. It means only that the walking was possible. There is a useful framing that some careful researchers use. They distinguish between the chain we can see and the chain we are still walking. The chain we can see is the chain behind us, the geological, biological, and cultural record of how we got here. That chain is partly knowable. We can read the fossil record. We can read the chemistry. We can read the slow accumulation of biological innovation across deep time. The chain we are still walking is invisible to us in the way that the future is always invisible. It is a chain whose links we are forming in real time with every century that passes. Our own contribution to that chain is being made right now. The filter ahead, if it is real, is at least partly being shaped by what we ourselves do in the next stretch of our history. That is a heavy observation. The video should hold it gently. It is not a prediction. It is an observation about where the chain itself lives. There is also, the chapter should say once, a soft observation about the symmetry of the two framings. If the filter is behind us, the discovery of life elsewhere, even very simple life, would gently reduce our confidence in the framing. The chain would have one fewer narrow place behind us. The silencing would have to lie further along. If the filter is ahead of us, the continued absence of life elsewhere, the continued discovery of habitable but uninhabited worlds, would gently strengthen the framing. The chain would have more time a wall. The chain would have more narrow places behind us than we thought, and the silencing would have less work to do up ahead. The two framings are not just abstractly related. They are tied together by what future observation can tell us. Every measurement of life elsewhere is a small statement about the location of the filter. We do not have those measurements yet. They will arrive, slowly, over decades. They will rearrange the question, even if they do not settle it. The chapter should also offer one more reflection. The filter behind and the filter ahead are framed, in much of the public conversation, as if they were two competing predictions. They are not predictions. They are descriptions of where the bottleneck might be. The bottleneck is not a thing to be predicted. It is a thing to be located. Locating it requires evidence we do not yet have. The honest expression of the framing is that the question is open, the evidence is incomplete, and the silence is patient. The chapter that follows will walk through the candidate filters one at a time in the same calm register, beginning with the candidates that may already be behind us. We are still walking the chain. We will walk it slowly. The night is long, and the chain is older than the night. Part 5. The filters that may lie behind us. We turn now to the candidate filters that may already be behind us. These are the steps along the chain that, if they are extraordinarily rare, could explain why a galaxy full of planets and chemistry and time is, nonetheless, a galaxy without neighbors. The video should walk through each candidate carefully, naming the mechanism and the reason it is taken seriously without amplifying it. The script should not declare a winner. The honest answer is that we do not know which candidate, if any, is the one. What we can do is set them out, side by side, and let the listener feel the shape of each. The first candidate, and in some ways the deepest, is the origin of life itself. The transition from non-living chemistry to a living cell is the most basic step in the entire chain. Everything else depends on it, and it is the candidate about which we know the least. We have one example. We know that life on Earth began within a few 100 million years of the planet's surface cooling enough to host liquid water. The geological record contains traces of biological activity in some of the oldest rocks that survive from that time. Life, at least once, was quick. But a single quick example tells us almost nothing about how often the transition takes place. It is possible that abiogenesis is the easy step, and that life arises almost everywhere the conditions allow. It is also possible that the chemistry of life is so improbable that, even given billions of habitable planets across the entire galaxy, it occurs only once in a region the size of the galaxy. With a single example, we cannot tell the difference. The origin of life is a filter candidate behind us, and one we cannot yet rule in or out. It is worth describing, in plain language, why the chemistry of life is so hard to think about. The molecules of life are large, complex, and arranged in highly specific ways. A protein is a chain of amino acids folded into a specific three-dimensional shape that carries out a specific function. A strand of nucleic acid is a chain of smaller molecules carrying a specific sequence that codes for the proteins. The cell that contains both of these is a microscopic factory, organized at every level for the work of staying alive and making more of itself. The question of how this kind of arrangement first emerged, from the simpler chemistry that the early Earth had to offer, is the question of how the building blocks of life already present in the universe came to be arranged into something that could maintain and reproduce itself. The chemistry that built the first cells has not yet been reconstructed in the laboratory. We can make many of the parts. We have not yet made the whole. Whether this is because the whole is genuinely rare, or because we have not yet been clever enough, is one of the open questions of the field. Either answer is consistent with the silence. The second candidate is the one many biologists treat as the strongest. It is the long jump from simple cells to complex ones. Life on Earth, after it began, spent roughly 2 billion years as nothing but single-celled organisms of the simplest kind. The Earth's surface was alive, but it was alive only at the microscopic scale, and only in the simplest possible architecture. Then, in what may have been a single event, one cell apparently took another inside itself and kept it alive there. The absorbed cell did not die. It became, over time, a small worker dedicated to producing energy for its larger host. That fusion of two cells into one is the event we now call endosymbiosis, and the cell that resulted is what we now call a eukaryote. Eukaryotic cells are the foundation of every plant on Earth, every animal, every fungus, and many of the more complex single-celled organisms. Without eukaryotes, there is no path to multicellular life, no path to bodies, no path to brains, and no path to a civilization that can ask questions. The reason this step is taken so seriously as a filter candidate is that, as far as we can tell, it happened only once in the entire history of life on Earth. Many other things in biology have happened many times. The invention of eyes, for example, has happened independently in many different lineages. But the fusion that produced the eukaryotic cell appears to have happened once, and every eukaryote alive today is descended from that single event. If the same is true on other worlds, if the jump from simple to complex cells is similarly rare, then most habitable planets that begin the path to life never get past the first stretch. They sit, for billions of years, as alive but simple worlds. The galaxy may be full of such worlds. The silence would be the silence of bacterial planets that never made the leap. The third candidate is the long chain of further transitions from complex cells to complex multicellular life. Even after the eukaryotic cell appeared on Earth, the further work of building tissues, organs, body plans, and nervous systems took another long stretch of time. The first multicellular life, small, soft-bodied colonies of cells, appears in the fossil record long after the first eukaryotes. The explosion of more complex body plans, with skeletons and shells and recognizable parts, happens later still. Each invention is a separate piece of biological architecture. Each was assembled under the long, slow pressure of natural selection across many millions of years. Each could, on another world, have failed to happen, or have happened later, or have stalled and gone no further. The point is not that any single one of these steps must be the filter, but that the cumulative product of several mildly difficult steps can be enough, on its own, to make the galaxy quiet. The fourth candidate is the emergence of the particular kind of mind that can ask the Fermi question. Earth has produced many kinds of intelligence, in cephalopods, in mammals, in birds, in social insects. Animals on this planet are clever in many different ways. But only one lineage in the entire history of life on Earth has produced the kind of mind that builds telescopes, that writes its questions down in symbols, and that aims its instruments at other stars. The contingencies that led to that lineage are many, and many of them could easily have gone otherwise. The use of fire, the development of hands that could grasp and shape and write, the development of language, which allowed knowledge to be shared across generations without being lost, the slow patience of a species willing to accumulate ideas over many lifetimes, rather than over the span of a single life. Each of those contingencies is a small piece of the chain. Each could have failed to occur. The kind of mind that asks the question is not the only kind of intelligence the universe might produce. It may not even be the most common kind. The galaxy might be full of intelligent creatures that are not, and never will be, technologically detectable. The silence would be the silence of clever animals who have no use for radio. It is worth pausing on this candidate because it carries a gentler weight than the others. The filter at this step would not be a death. It would not be an extinction. It would simply be the observation that minds capable of building radios and listening for replies are uncommon. There can be alive and clever worlds without anyone on them ever turning a satellite toward the sky. The silence, in this framing, is not the silence of empty planets, It is the silence of planets full of life that never developed the impulse to ask. There is a fifth candidate worth naming briefly, because it overlaps the others and complicates any easy reading of them. The fifth is the long compounding of all of the earlier transitions together. A planet must be in the right place. It must develop liquid water. It must develop the chemistry of life. It must keep that chemistry stable long enough for biology to settle in. It must avoid the catastrophes, large impacts, sterilizing radiation, the loss of its atmosphere that could remove all of the early progress. It must develop complex cells. It must develop multicellular life. It must develop bodies, brains, and minds. It must develop language, technology, and the patience to build instruments. And only then does the question of communication even arise. Each of these is a step. Each has a probability less than 1. The product of all of them is the number we are trying to recover. None of them, on its own, may be the filter. The filter may be the cumulative weight of all of them, the long, quiet narrowing of the chain at every link. The video should resist the urge to declare which of these candidates is the most likely. The honest answer is that we do not yet know. Different researchers, looking at the same evidence, place different weights on different candidates. The biologist who is most impressed by the rarity of the eukaryotic cell will tend to favor the second candidate. The chemist who is most impressed by the difficulty of building self-replicating molecules from non-living parts will tend to favor the first. The anthropologist who is most impressed by the contingencies of language and technology will tend to favor the fourth. Each is reasoning carefully from the evidence available. Each is reasoning with care. And each is, in the end, reasoning from a single example, which is the strongest reminder that the question is far from settled. What the candidates share, taken together, is a calm, common conclusion. The chain from a habitable planet to a technological civilization is long. It contains several narrow places. We have walked all the way through it, on this one planet. We do not know which of the narrow places almost stopped us, or whether all of them did, each one only just barely letting us through. We do know that we are here, listening, on a planet that, by every measure, took a long and contingent path to get to the present moment. The filter behind us may be one step, or it may be many. Either way, the chain we walked is a quiet, improbable thing. It is worth holding the chain gently, the way one holds something old and unusual, and acknowledging how much of it we did not choose. But the filter behind is only one of the two locations. The other location is ahead. The chain has not finished. We do not know whether there is still a narrow place we have not yet reached. We do not know what the long, deep future will demand of any civilization that hopes to be heard across the galactic distances. The next chapter will walk slowly through the candidate filters that may lie ahead of us, with the same calm and with the same patience the question deserves. The night is long. The chain is long. We are walking it together. And to the candidates ahead, we now turn. There is a deeper observation about the chain of biological transitions that the video should sit with for a moment before moving on. The chain on Earth was not a straight line. It was full of turns, dead ends, and slow recoveries from setbacks. Several times during the history of life on this planet, the biosphere came close to ending. Large fractions of the species alive at the time were lost. The records of those events are written into the rocks. The biosphere recovered each time, slowly, but the recovery was not guaranteed. Each setback was an opportunity for the chain to fail, and on a different planet, the chain might have failed on the very next setback. The fact that Earth's chain has continued through every setback so far is, in some real sense, a piece of luck. Other planets in the galaxy may have lost their chains at events of the same kind. The galaxy may be full of worlds that began the path and were stopped by ordinary cosmic accidents, by impacts, by stellar instabilities, by changes in their own atmospheres that the biosphere could not recover from. These are not filter candidates in the strict sense, because they are not specific to any one step in the chain. They are background hazards that apply to every step. They are part of what makes the chain narrow. There is also the observation that the chain on Earth was not driven by any single agent. No part of the biosphere planned to become a civilization. Every step was the result of selection pressures acting on populations of organisms that had no awareness of where the chain was going. The chain emerged from the slow accumulation of small improvements, each one useful in its own moment, that together built the architecture for the next step. The eukaryotic cell did not know it was building toward multicellularity. Multicellular life did not know it was building toward nervous systems. Nervous systems did not know they were building toward language. Each step was its own destination, made of its own small reasons. The chain emerges only in retrospect. From inside the chain, no one is walking toward anything. It is only from outside, looking back, that the chain looks like a path. This is a calming observation, in its way. It means that the chain is not a project that any civilization is consciously completing. It is a chain that completes itself, when it completes, through the slow patience of evolution. The filter, if it lies in any of these biological transitions, is not the failure of a project. It is the failure of a probability to come due. The chain is walked by no one in particular. That is part of why the silence is so large. There is no agent making sure the chain finishes. The chain finishes only when the small accidents accumulate in the right order. On most planets, they apparently do not. There is one more candidate in the past chain that the video can name, briefly, before moving on. It is the candidate of the long, stable surface. For a planet to develop complex life, its surface must remain habitable for a very long time. The Earth has had several billion years of relatively stable surface conditions. Other planets in the galaxy may not have had the same fortune. A planet whose orbit is slightly less stable, or whose star is slightly more variable, or whose own internal heat decays slightly faster, may have a window for complex life that is much shorter than Earth's. The chain on such a planet might begin many times and break many times without ever reaching the further links. Stability over deep time is itself a candidate filter. The fact that Earth has been stable for as long as it has is part of the chain we have walked, and not all planets may share that good fortune. These observations should be held with care. They are not predictions about other planets. They are observations about the chain we walked and about the kinds of things that could have stopped it on a different world. The filter behind, taken seriously, is a recognition that the chain on Earth went through many narrow places, and that on most planets, the chain probably did not. We are an unusual outcome of an ordinary universe. Or, in a slightly different framing, we are an ordinary outcome of an unusual planet. The chain we walked is the chain we walked. Other chains may have started and stopped in many other places for many ordinary reasons. The chapter should let this rest where it lies and turn next to the chain that has not yet been walked. The chain ahead of us is invisible from where we stand. We do not know which of its links are narrow, or what shape its narrowness will take, or whether we will recognize the narrow places when we reach them. The candidates we will turn to next are not predictions either. They are descriptions of the kinds of barriers that, if they exist, would be consistent with the silence. To those candidates, with the same calm we have brought to these, we now turn. Part 6. The filters that may lie ahead of us. We turn now to the candidate filters that may lie ahead. These are the steps along the chain that, if they are extraordinarily difficult, would explain why a galaxy full of civilizations that began somewhere along the same chain has produced no civilizations that have grown large enough or stable enough to be heard. We will move through them in the same calm register as the previous chapter. We are not building toward a single answer. We are walking through possibilities. The honest position remains that we do not yet know which of these, if any, is the one. The first candidate ahead is the simplest and the most familiar. It is the long, fragile window between developing the capacity to alter a planet and learning to manage that capacity wisely. A civilization that has reached the level of being technologically detectable has, by definition, developed industrial-scale machinery. That machinery, by its nature, can change the atmosphere of its planet, the climate of its world, the chemistry of its oceans, and the genetic record of life on its surface. Earth's history shows that these changes can happen within a few generations. The window between developing the capacity and learning to use it without harming the long-term habitability of the planet is, on planetary timescales, very short. It is possible, though it is not yet measured, and may never be measurable from the outside, that most civilizations fail to make that crossing. They alter their worlds before they understand them well enough to keep their worlds. The filter, in this framing, is the small window of time between technological adolescence and technological maturity, and the difficulty of remaining alive in the window long enough to walk through it. This framing should not be read as a prediction. It is a description of a possibility consistent with the silence. The video should name it, allow its weight, and move on. The voice does not need to dramatize. Civilizations that have crossed the window successfully would be quiet for a long time before they grew loud again. We do not know how many have crossed. We do not know how many have not. The silence is consistent with both an honest, small number of failed crossings and a much larger number. We are walking through possibilities. The second candidate ahead is the development of self-replicating machinery, biological, mechanical, or computational, that, once released, becomes difficult to recall. The danger here is not the machinery itself. The danger is the loss of any single decision-maker's ability to reverse a course once it is set in motion. A civilization that builds a tool of this kind is, in effect, betting that the tool will continue to behave as intended for the entire span of its existence. If the tool ever behaves otherwise, and if the civilization has not preserved a way to recall or replace it, the bet has gone wrong. Whether this danger is large or small is unknown. It is a filter candidate because the same capacity that lets a civilization spread among the stars also lets it remove itself from its own planet without intending to. The chain that builds a starship is the same chain that builds the unrecallable tool. Walking the chain successfully requires more than just the ability to build. It requires the patience and the wisdom to choose, repeatedly, not to release what cannot be brought back. A third candidate is the slow attrition of an indefinitely long arms race. Even small probabilities of catastrophic events become near certain over long time horizons. A civilization that survives 1 century with weapons of a certain kind must survive 10 centuries, and 100, and 1,000. A civilization that hopes to be heard from across the galactic distances must persist for a very long time. Even a small per-century probability of catastrophic failure compounds across deep time into a near-certain ending. The filter, in this framing, is not a single event, but a slow drain on the population of civilizations across the long arc of their existence. Each century, a small fraction fail. After many centuries, almost all of them have failed, even if each individual century looked perfectly survivable. The galaxy would be quiet because the survival problem is not a one-time test, but a long, slow, recurring one, and very few civilizations survive every roll of every century's dice. A fourth candidate is the gentler one we touched on at the end of the previous chapter, and it deserves a longer look here. The fourth candidate is the turn inward. A civilization that develops the capacity to leave its planet may also, with time, develop the capacity to be perfectly content where it is. It may build the kind of internal worlds, virtual, contemplative, abundant, that make the external world less interesting. It may discover that the deep questions can be answered with less and less expenditure of energy and material, the more sophisticated its tools become. A civilization that becomes more capable in this way would emit less waste heat, not more. It would broadcast less, not more. It would, in the long run, become harder to detect, not easier. A galaxy full of such civilizations would be quiet for reasons that have nothing to do with extinction. The silence would simply be the sound of maturity. Quiet civilizations are a softer filter than the others, but they are a real possibility, and the video should name them with the same care. There is a fifth candidate worth naming for completeness. It is the candidate of the honest unknown. The history of science suggests that some of the largest hazards to a civilization have been discovered only after a civilization developed the capacity to interact with them. Hazards we now consider familiar: the chemical instability of certain combinations of materials, the genetic risks of certain biological modifications, the energetic risks of certain physical reactions were once invisible. There may be a filter ahead of us whose nature we will not understand until we are inside it. This is the calm version of the same observation, held without alarm. The universe sometimes surprises its inhabitants, and the surprise can be large. The video should name this candidate not to alarm anyone, but to be honest about the limits of what we can currently see. The chain has stretches we have not yet walked. The narrowing of the chain along those stretches is not yet visible. There is also, the video should say in passing, a sixth framing that overlaps the others. The sixth is the framing of the cumulative future filter. Just as the past chain may have been narrow because of the accumulated weight of many small bottlenecks, the future chain may be narrow for the same reason. A civilization that wishes to be heard across the galactic distances must persist long enough, must remain interested long enough, must remain capable long enough, must remain unified enough, and must remain audible long enough, and the product of all those factors, each less than one, may be the silence we observe. The future filter, like the past filter, may not be one wall. It may be the cumulative thinning of a chain stretched across deep time. What ties these candidates together, taken as a group, is that none of them require a single dramatic event. None of them require a particular catastrophe. None of them require any specific scenario. They require only that the long average of survival, capability, and audibility be a quiet number. The galaxy could be silent because of one large barrier, or because of many small ones, or because of the slow erosion of the conditions for being heard, or because civilizations grow inward rather than outward as they mature. The silence is consistent with all of these. It does not yet distinguish between them. This is the honest position. The filter if it lies ahead, is somewhere along the road from where we are now to the long, deep future. We cannot see it from here. We do not know what it looks like. We do not know whether it is one barrier or many. We do not know whether it is a death or a turn or a slow attrition or a discovery yet to be made. We only know, from the silence of the galaxy, that something happens to almost everyone who has begun the chain. The something is enough to remove them from the audible part of the sky. The video should let this rest where it lies. It is not a prediction. It is a description. There is a calm thought the video can hold here before it moves on. The filter ahead, if real, is a problem that civilizations face individually. Each one walks the chain alone. Each one makes its own decisions, builds its own tools, accumulates its own knowledge, and faces its own narrow places. The silence we observe is the cumulative record of many individual walks, each of which ended somewhere. It is not the verdict of a single jury. It is the long average of many separate stories. Our own story is one of those stories. We are walking the same chain. We have not yet reached the place where the others appear to have stopped. Whether we will reach it and whether we will pass through it is a question we cannot answer from here. It is a question we can only walk slowly toward, 1 century at a time. We will turn next to the silence itself, not as a problem to be explained, but as a measurement, a fact about what the universe has shown us when we listen carefully. The silence is the strongest piece of evidence we have. It is also the quietest. To the silence, and to what it has already told us, we now turn. There is a reflection worth offering about the difference between past filters and future filters that the active chapter has not yet made explicit. Past filters can, in principle, be studied. The fossil record, the chemistry of meteorites, the architecture of cells, these are all observable. A researcher with patience and the right instruments can, over time, narrow down which of the past filters are most likely the major ones. Future filters cannot be studied in the same way. They are not yet observable. We are inside them, walking through them, with no clear view of where the walls are. The asymmetry between knowable past and unknowable future is part of what makes the question difficult. We can, in time, learn quite a lot about whether life is rare. We can learn less, on a similar timescale, about whether civilizations are durable. There is also a calmer observation about the time horizon of the future filters. The filter behind us, if it is real, has already happened. It is done. It is finished. We do not need to do anything about it. The filter ahead of us, if it is real, is something that is unfolding now, slowly, over centuries and millennia. It is not a single moment. It is a long stretch of conditions that civilizations must, somehow, walk through. The slowness matters. A future filter that takes 10,000 years to unfold is not a problem that any single decade can solve, and it is not a problem that any single decade can fail to solve either. It is a problem that requires patience across many generations. That is, on its own, a calming observation. The chain is not finished by 1 century. It is not broken by 1 century either. It is walked, slowly, across many. There is a further reflection on the turn inward candidate that deserves more attention. The idea that mature civilizations may grow quieter rather than louder is not, on first hearing, intuitive. The popular imagination of an advanced civilization is of one that is louder, larger, brighter, more visible. The actual physics of advanced engineering suggests something more subtle. The most efficient use of energy is the one that wastes the least heat. The most efficient communication is the one that uses the narrowest beam to the smallest audience. The most efficient civilization is one that, in many ways, leaves no obvious footprint. A civilization that has optimized itself for efficiency may, paradoxically, be harder to detect than a civilization that has not. The galaxy may be full of mature civilizations that have made themselves indistinguishable from nature, simply by being good at what they do. This is not an alarming observation, and the video should not present it as one. It is, in some ways, a reassuring observation. It suggests that the silence we observe is not necessarily a sign of failure. It may be a sign of success of a particular kind, the kind of success that does not need to announce itself across the galaxy. A galaxy of quiet, efficient, contemplative civilizations would look identical to a galaxy of empty planets. The data so far cannot tell the two apart. The video should let this possibility sit with the listener, calmly, as one of the real options. There is also a thought worth holding gently about the relationship between the future filter and our own choices. The filter ahead, whatever it is partly something we will shape by what we do. The lifetime of our own detectable signature depends on whether we continue to be the kind of civilization that has a detectable signature. The audibility of any future contribution we make to the galactic record depends on whether we keep making contributions. The chain ahead is partly written by the universe and partly written by us. The proportions are not knowable from here. But the fact that the chain is partly written by us is, in itself, a reason for the calmness the video has tried to maintain throughout. The chain is not a chain that is being done to us. It is a chain we are walking. We are still walking it. That is, in the end, the simplest, honest expression of where we stand. The chapter will close, then, with a soft acknowledgement that the candidates ahead are real possibilities, that they are not predictions, that the universe will surprise us in ways we cannot predict, and that the chain we are walking is the only chain we have to walk. The silence will keep being measured. The candidates will keep being studied. The chain will keep being walked, slowly, century by century, by everyone who walks it with us and by everyone who walks it after us. The night will be patient. The chain is older than the night. Part 7. The silence itself and what it has already told us. The last chapter of this video belongs to the silence. The strongest piece of evidence for the Great Filter is, in some ways, the simplest. It is the observed quiet of the galaxy itself. The video should walk slowly through what has been searched and what has not yet been found, in a voice that treats the silence as a measurement rather than as a problem. The silence is what the universe has shown us when we have asked it patient and careful questions. It is not the absence of looking. It is the result of looking. It is a finding in its own right. The looking has gone on for many decades. It has used many different instruments in many different parts of the sky, across many different wavelengths. It has used radio telescopes, listening for narrow bands of frequency that would indicate a directed transmission, rather than the broad hum of natural emission. It has used optical telescopes, watching for short, bright laser pulses that would briefly outshine the natural light of a star. It has used infrared surveys, looking for the excess waste heat that a civilization would emit if it surrounded its star with collectors, or used a substantial fraction of its star's light for its own purposes. It has used transit surveys, originally designed to find planets, to look for the unusual shapes that might indicate large artificial objects passing in front of distant stars. It has used the patient examination of objects passing through our own solar system, weighing whether each unusual visitor could be explained by ordinary causes or required something more. The looking has been honest. It has been thorough. It has been carried out with the calm patience of careful observers. What the looking has found is the natural universe. It has found the background of the cosmos. It has found rotating neutron stars whose pulses, when first detected, were briefly mistaken for signals from another civilization, before careful study revealed their natural origin. It has found molecular clouds whose chemistry is rich but undirected. It has found stars surrounded by ordinary dust. It has found dust that absorbs and re-radiates the light of its star without any sign of organized arrangement. It has found unusual objects whose unusual features have, in every case so far, resolved into natural phenomena or into instrumental artifacts on closer examination. The few candidate signals that have caught the attention of the field have, after careful study, settled back into the natural background. The search has been honest. The result has been the same. This is the silence the video has been building toward. It is not the silence of having looked once and given up. It is the silence that emerges when many people, working independently, looking with different instruments at different parts of the sky for many years, all arrive at the same finding. It is a silence with structure. It is a silence we have measured. It is, in the language of a careful observer, a finding. The video should walk briefly through what the silence does not yet rule out, because the honest expression of any measurement includes the things the measurement cannot yet see. The searches have been thorough, but they have not been infinite. We have looked carefully at many hundreds of nearby stars and at many thousands more in less detail. We have looked at many galaxies' worth of stellar populations for the infrared signature of large-scale engineering. But the observable universe contains hundreds of billions of galaxies, and the visible region we can carefully examine is only a small fraction of that total. The silence we have measured is, in the strict accounting, the silence of the part of the sky we have been able to look at carefully. The rest of the sky remains unmeasured. The silence we have found is consistent with a galaxy in which no civilization is currently audible, and with a galaxy in which audible civilizations exist, but at frequencies, or in directions, or at times, that we have not yet sampled. The video should also be honest about the limits of what the searches have been able to detect. The narrowband radio searches have been sensitive enough to detect transmissions of the kind we ourselves emit, but only out to a small fraction of the galaxy. A civilization much like ours, broadcasting at the levels we broadcast, would not be detectable from across the disk. The infrared searches have been sensitive enough to detect very large-scale engineering, but not the more modest scales that smaller civilizations might use. The transit surveys have been sensitive enough to detect very large artificial objects, but not the smaller probes that a quieter civilization might prefer. The silence we have measured is the silence of the things we are currently equipped to find. Civilizations using technologies different from our own, or operating at scales different from our own, would not necessarily appear in the data. This is part of what makes the silence so quietly serious. The searches have not failed to find civilizations because the searches have been careless. They have not failed to find civilizations because the searches have looked in the wrong place. They have, by every reasonable measure, looked carefully at the kinds of signals that ought to be there, in the parts of the sky where ought to be there, with sensitivities sufficient to detect signals of the kinds we know how to make. And the searches have found nothing. The natural universe has answered every question. The artificial universe has, so far, remained absent. The silence has another property worth describing slowly. It is consistent across approaches. Whether one looks for radio or for laser, or for waste heat, or for transits, or for visitors, the same answer comes back. The natural universe is full of light and quiet and ordinary phenomena. The artificial universe, the universe of organized purpose, of directed signals, of unmistakable industry, does not appear in the data. If only one search had returned a null result, it would be tempting to look to that search for the explanation. But every search has returned the same answer. The silence is not the property of a single instrument. The silence is the property of the sky. What does the silence tell us, taken seriously as a measurement? It tells us several things, in calm and careful order. It tells us, first, that audible civilizations are not common in the part of the galaxy we have been able to study so far. It tells us, second, that whatever fraction of stars in the galaxy might host civilizations capable of being heard at our current detection thresholds, that fraction is small. It tells us, third, that the early factors in the chain, the abundance of stars, the abundance of planets, the abundance of habitable worlds, cannot be the whole story. Something in the later factors is doing the silencing. It tells us, fourth, that the silence is robust across many different ways of asking the question. It is not an artifact of one method. It is the answer the universe gives when we ask it carefully. It does not tell us where the filter is. It does not tell us what shape the filter takes. It does not tell us whether we have already passed it or whether we have not yet reached it. It only tells us that the chain ends somewhere in quiet. We are listening, and the universe is listening back, and what we hear is the natural cosmos doing what the natural cosmos does. The voices we hope to hear are not, so far, in the data. There is a softening the video can do here before it closes. The night sky, taken as silence, is also taken as company. The universe is not actively against us. It simply is. The light that arrives at the telescope is not an absence of signal. It is a presence of everything else: galaxies, stars, gas, dust, time. The quiet of the cosmos is not the same as loneliness. The absence of voices is not the same as the absence of company. The stars are still there. The galaxies still rotate. The molecular clouds still hold their slow chemistry. The cosmos remains, and remains beautiful, even in the absence of neighbors. There is a kind of patience in the silence that does not feel hostile when you sit with it for long enough. It feels, instead, old. It feels familiar. It feels, in a calm way, like the kind of company that asks nothing of you. There is also a long view the video can take, gently, before the closing. Even if the filter is real, and even if it is ahead of us, the universe has a great deal of time still to run. Stars will continue to form. Habitable planets will continue to exist. The cosmos will host the conditions for life for many tens of billions of years to come. Whatever happens to the present generation of civilizations, the universe will keep trying. The filter is not the end of the story. It is the difficulty of one particular kind of crossing, on a stage that is much larger and much older than any single attempt. The chain will be walked again, somewhere else, by something else, in a time longer than we can easily picture. The galaxy will not be empty forever. It is only quiet, for now. What does it mean that we are here at all? The video can offer a quiet thought without insisting on it. It means that we have, by whatever combination of luck and slow work, walked a long chain to its present link. It means that we are alive on a planet that took billions of years to produce minds capable of asking the question. It means that we are listening in a universe that has so far not given us a voice to answer with. The filter behind us, if it is real, is something we have already crossed without knowing it. The filter ahead, if it is real, is something we have not yet reached. We are here, between the two, on a small, bright world, looking outward. That is the position we are in. It is worth holding the position calmly. It is not a triumph. It is not a tragedy. It is the honest condition of an early civilization in a quiet universe. The fear in the title was the bait. The truth in the body is the calm one. We are listening. We are still here. The silence, for now, is the question itself. We do not know which side of the filter we are on. We do not know whether we have already done the hardest thing or whether the hardest thing is still ahead. We know only that the sky has held its quiet for a very long time and that the listening will continue. The patience is the work. The patience is also the answer, in its way. There is a final, very quiet way to hold the silence before the closing arrives. The universe, in its long history, has produced many quiet places. It has produced quiet planets where life never began. It has produced quiet moons where the ice never broke. It has produced quiet stars that burned out before their planets could form anything more complicated than weather. The galaxy is, in many ways, mostly quiet. The places where it is loud, in any measurable sense, are very few and very localized. The silence we observe is not, perhaps, the strangest feature of the universe. The strangest feature of the universe may be that it produces, in its vast quiet, the occasional very small place where something is paying attention. Earth, at the present moment, is one of those places. The silence around us is not so different from the silence that almost every other part of the universe also holds. What is unusual is not the silence. What is unusual is the listening. The listening is the rare thing. And the listening, for tonight, is enough. The chain we are walking is being walked, at this moment, by us. The instruments that listen are listening, even tonight. The patient people who study these questions are studying them, even tonight. The night is long, and the question is long, and the listening is long. We do not know how the question will resolve. We may not be the ones who see it resolved. But the work of holding the question carefully, of listening calmly, of letting the silence be what it is that work is ours, and it is enough work for tonight. The fear in the title was the bait. The truth in the body is the slow, patient one. We are still here. We are still listening. The chain is older than we are, and the chain will continue after us, and the question itself is, in the end, the kind of company the universe offers to those who are willing to sit with it for long enough. The silence is the question. The listening is the answer. Both will continue. Both are old. Both are quiet. Both are, for now, enough. And so we set the question down where we found it, at the edge of a sky that has held its silence for a very long time. We do not yet know which side of the filter we are on, and that is a quieter thing than it sounds. The universe is not against us. It is simply old and patient and listening the way we are listening. The night will keep its quiet whether we solve the question tonight or not. Let your breathing slow. Let your thoughts settle. Sleep well and good night. There is a slow reflection worth offering in this final chapter on what listening to the silence actually feels like from the inside. The instruments that listen are large radio telescopes that spend many hours pointed at single stars, gathering the faint radio signals that ordinary stars and the gas between them produce. The instruments are quiet places. The data they produce is, for the most part, a long, flat record of ordinary cosmic activity. Most nights, nothing happens. Most nights, the sky is exactly what the sky has been on all the other nights. The work of listening is the work of being patient with that ordinary record, of staying alert for anything that is not ordinary, of resisting the temptation to read significance into noise. The work of listening is, in many ways, the most patient work in astronomy. It is the work of paying close attention to silence. What this kind of work has produced, over many decades, is a deeper understanding of what the natural universe sounds like. We have learned, in great detail, what kinds of signals stars emit. We have learned what kinds of signals come from rotating neutron stars, from molecular clouds, from the slow turning of the galactic background. We have learned what kinds of signals come from our own atmosphere, from our own instruments, from human activity on the surface of our own planet. The work of distinguishing artificial signals from natural ones has become more refined with each passing decade. The threshold for what counts as unusual has risen. The candidate signals that survive scrutiny have become fewer. The silence has tightened, in the same way that a measurement tightens over time. The silence we have measured today is more carefully measured than the silence we had measured a generation ago, and the silence a generation ago was more carefully measured than the silence before that. The measurement is becoming better. The result is becoming the same. This is a useful observation to hold. The silence is not a static fact. It is a moving measurement that gets more precise as the instruments get better and as the methods get more refined. A silence that has tightened over many decades is a more meaningful silence than a silence measured once and never measured again. The fact that the silence has held across many different searches, with many different instruments, by many different researchers, over many different decades, is part of what gives the silence its weight as evidence. It is not a single null result. It is a long string of null results, each one independent, each one consistent with the others. That kind of agreement is rare in science. It usually means something. There is a complementary observation about the limits of what we know. We have, by every reasonable measure, looked carefully at only a small fraction of the galaxy. The galaxy is vast. The instruments are sensitive, but they are not infinite. The sky has not all been examined at the same depth. Some parts of the sky have been studied in great detail. Other parts have barely been studied at all. The silence we have measured is the silence of the parts we have looked at. The parts we have not looked at remain unmeasured. This is not a softening of the result. It is a careful accounting of what the result includes. The silence is real. The completeness of the search is not. There is also a quieter observation worth offering in this closing chapter about the relationship between listening and being heard. The instruments we use to listen are, in their nature, also instruments that could, in principle, broadcast. The question of whether to broadcast, whether to send a deliberate signal that could be detected by another civilization, is a question that has been carefully considered and on which careful people have disagreed. Some have argued that the long-term safety of the species requires us to remain quiet on the principle that we do not know what would respond if we were heard. Others have argued that the question is misplaced because the ordinary leakage of our own technology has already made us detectable to any civilization equipped to detect us. The argument continues. The video does not need to settle it. It can simply observe that the question of being heard is the mirror image of the question of hearing. Both are old. Both are unresolved. Both will be carried forward by the people who come after us, who will face the same questions with, perhaps, slightly better instruments and slightly more data. There is also, in this closing chapter, a slow observation about what the silence has not yet ruled out. It has not ruled out the possibility that civilizations exist, but at distances or in directions or at times that we have not been able to sample. It has not ruled out the possibility that civilizations exist, but communicate at wavelengths we have not yet examined carefully. It has not ruled out the possibility that civilizations exist, but are quiet by choice. It has not ruled out the possibility that we are, simply, the first, or among the first, to walk the chain to its present link. The silence is consistent with many things. The Great Filter is one of them. The Great Filter is, in some ways, the heaviest of the consistent answers, but it is not the only one. The video should be honest about that. The question remains open. What the silence has done, with great care, is to make the question pointed. It has narrowed the space of possibilities. It has told us, with growing confidence, that civilizations of the kind we know how to look for are not common in the parts of the galaxy we have been able to study. It has told us that something in the chain somewhere is doing the work of the silencing. It has not told us what that something is. But it has told us that it exists, and that the question of where it sits along the chain is a real question, and that the question deserves the patient consideration the video has tried to give it. The silence is not, in the end, just an absence. It is an answer of a particular kind, the answer that says, gently, that the question is harder than it first appeared. There is one more thing worth saying before the video closes. The Great Filter, taken seriously, is a question that is much larger than any single century can answer. It is a question that the people who come after us will continue to ask, with better instruments and more data, in ways we cannot yet imagine. It is a question that may, in the long course of time, be answered by an unambiguous discovery, a signal, an artifact, a clear sign of life, or it may continue to be a question for many generations more. We do not know how long the question will remain open. We know only that it is open now, and that the listening is continuing, and that the chain is being walked by us and by everyone who comes after us. The question is ours to hold, calmly, for as long as we are here. The night is long. The chain is older than the night. The listening continues.